Hi everybody, this is going to be a very short video about residuals explaining these notes, so please watch it. I promise it'll be quick. Okay, so if you guys notice here, I made a scatter plot between days and numbers of bacteria. You can see from the points that it's not exactly linear, it's actually exponential because bacteria growth is exponential in nature because it's repeated multiplication. So this is actually not a good linear regression model because the data, as you can see, is nonlinear. Okay, so what I did here was calculated the regression equation using the calculator. A residual is actually the distance between, an easier way of explaining it is it's really the distance between the point and the line. It's the difference between what you predicted and what actually happened. Okay, so let's take that a step further and look at it. I'm going to zoom in here. If you guys notice this point right here, that's the point 5 comma 80, right? So that's 5 comma 80, which means that the actual y value for this point is 80, right? And then what you're going to do is if you were to actually predict if you were to predict y hat, which you get by plugging into the equation at this point, what you would do is you would substitute into the equation and that point would actually be on the line. Y hat is always on the line because the line represents your linear model. So the residual would be the distance between y and y hat. So if you guys notice for this point, the residual should be negative because the point is below the line. If the point is above the line like this one, then the residual should be positive. Okay, so to calculate a residual algebraically, what you need to do is, well, you have to do it point by point, literally. So for the first point, like that I just did an example where x is 3, we notice that the y value for that is 24. Okay, so 324. And then you're going to actually calculate y hat. You calculate that by plugging x into the equation, and I got y hat equals 40.89. So if you notice, this is the this is the actual value, and this is the predicted value. So the residual, you literally just subtract them. So you're going to take your y value first, and then subtract your y hat value for a certain point. So what I did was I did 24 minus 40.89, and I got negative 16.89, which is good because, as I told you guys, the point is below the line. Okay, so now let's move on to this. I'm going to zoom out a little bit. The residual plot. So a residual plot is a plot that will tell you whether or not your data is linear in nature. So they're important. You're going to have to make some yourself. So here's what people normally do. They make a chart with 4 parts, x, y, y hat, and residual. You're actually going to ignore both y and y hat. So the only numbers you really need in your chart are x and the residual because that's what you're going to plot here. So on your graph, what you do is you make x the x-axis. That makes sense, right? And then your y is actually taken up by the residual value, not y or y hat. So you guys notice that I plotted the residuals along the y-axis. And then you want to check whether or not your data makes a pattern. So if there's pattern, then that's evidence that your data is actually non-linear. So basically, in this problem, I got a shape that looks pretty quadratic. Like if I were to draw a line on it, it's kind of like a parabola, you know? So basically, this is a quadratic pattern. So that means that the data is not linear. Was our data linear in the beginning? No, it wasn't. It was exponential growth. So basically, if you see a pattern in the residual plot, it means your data is nonlinear. If you don't see a pattern, like if the points are just randomly scattered everywhere, that's actually a good thing. That means that your data is linear. So it's really important to distinguish that, like between linear and nonlinear data. So obviously, if it makes a pattern, it's nonlinear. So if it doesn't make a pattern, then the data is linear. Okay, so you guys feel free to text me if you have questions. I'm going to cut this off to keep it short, and that's it.